Up until now, when we've been dealing with the topic orthographic projection has dealt with elevation, so looking at the front of an object, plan, looking down from the top of an object, and in view, looking directly in at the side of an object. But up until now, we've always looked straight in at the front, straight in at the side, or straight down on the top. We're going to be getting to auxiliary elevation, which is where we're going to look at a view in between the front and the side view. In other words, it's not looking straight in from the front, it's not looking straight in from the side, it's looking in at a random angle in here someplace. And this is what an auxiliary elevation is all about. I'm going to start with just a normal elevation first of all, and then we'll show the similarities between a regular elevation and an auxiliary elevation. So my regular elevation, I have to look directly in at 90 degrees to the front of this box. The box is 50 mm wide, 30 mm high, and then it is 20 mm from the back to the front. So I'm going to draw an elevation and plan, normal elevation and plan, looking in at this object, and I'm going to start with the plan. So I'll keep the box out to the side there a little bit. So for me to draw this, I always start off. We have an XY line normally drawn in. Now I'm going to do it a little bit backwards first of all. I'm going to come and I'm going to draw the box in first of all. So the plan view is what I'm going to draw in here. And I see the box in plan is going to be 50 wide and 20 from back to front. So I'm going to measure out 50 mm wide and make the box 20 from back to front. There is my plan view. So 50 by 20 for the plan. From there I'm going to start drawing in my elevation. To draw the elevation, I'm going to stand out in front of the box. Here's the front of the box. Here's my eye looking directly in at it. In the plan view, this is the front of the box. This edge is the front of the box. So I need to stand directly out in front. Here's where my eye is going to be. And I'm going to look in, directly in at 90 degrees to the box. So I'm looking in here. That is where my view comes from. That's what we call my line of sight. I'm standing out in front of the box, and now I'm going to come along and draw a line of sight. It's from that line that I project my elevation. So it just so happens that that line is straight up. So when I project up, I'm going to project my elevation up. For our elevation, we always have an XY line. I'm going to step up 20 mm, and I'm going to draw my XY line. So there's my XY line put in. And now I'll go and draw the elevation. The elevation again is 50 mm wide, same as the plan, and the height of the box is 30 mm. I've already brought up my width. I'm going to measure the height of the box, which is 30. So up to 30 mm. And that is my finished plan and elevation drawing. Now, there's a couple of important things to note. I have my line of sight coming in, and you'll notice the line of sight, very importantly, makes an angle of 90 degrees. So the XY line and the line of sight are at 90 degrees to each other. And then in the elevation, we measured height. So in other words, the height of the box was 30. Here's the height of the box, 30 mm. I'm going to go now and I'm going to draw what's called an auxiliary elevation. So I'm going to start off by drawing the plan of the box again, and I'm going to do the same process. Okay, so I've got my plan view drawn exactly the same as the last view. So again, I've got my box here. So in the plan, it was 50 mm wide, 20 mm from back to front. I want to draw an auxiliary elevation now, so a different elevation, and what I'm going to draw is an auxiliary elevation looking in at 30 degrees. The original elevation I drew was me looking in here at an angle of 90 degrees. So 90 degrees was this angle here. So that's me drawing an elevation looking in at an angle of 90 degrees. It's our standard elevation. I'm going to draw an elevation looking in at 30 degrees. So what I'm going to do is get my 30 degree set square, and I'm going to look in here. My eye is here now. So what it means is that I'm not standing looking in at the front of the object anymore. Now I'm coming around and I'm standing looking in at both the front and the side of the object. So when I come to draw this, I'm going to see the front of the object as well as this side. So I'm going to see the two surfaces in this view. Whereas in this one, I only see the front. The rules we're going to use are absolutely the exact same. So to start off my original elevation, I have my line of sight drawn in. I'm going to draw in my line of sight. We said it's at 30 degrees. So I'm just going to come along, draw 30-degree angle. Here is my line of sight. I'll darken it a little bit so you can see it. The XY line is at 90 degrees to the line of sight. So here's my XY line, angle of 90 degrees to the line of sight. Here's my line of sight. I want to set up a line at 90 degrees to it. To do that, I use this other side of the set square. So 90 degrees to that is here. I'm going to use the 60 degree side of the set square. So now I've got my new XY line. So in this case, the XY line is at the side. It's at a bit of an angle. That doesn't matter. My points that I brought up, so you can see I brought up my points to elevation, brought the points up to elevation. And if you notice, they are parallel to this line of sight. Here's my line of sight. This line is parallel. So I do exactly the same thing. I'm going to come along, take up my points, and they're all going parallel to the original one. So my original line here, I drew with the 30 degree set square. I'm drawing these ones with the 30 degree set square. To draw my original elevation, I measured the height of 30 millimeters because the box is 30 mil high. I do the same here. I come along from my XY line and I measure up a height of 30 millimeters. So I've got the height of the box. Last part, you can see that the top of the box is parallel to the XY line. The top of the box is horizontal, it's level. So you can see top of the box parallel to the XY line. So again, I need to make the top of the box parallel to the XY line. And to do that, I use my 60 degree set square. So the 60 degree angle now, I'm going to come along and draw that in. That gives me my auxiliary elevation. Here is my auxiliary elevation. And what it's showing me is the front. Here's the front of the box. And it looks like it's been squished up a little bit, which is the front of the box. And then I've got the side of the box, which is represented here, which is a little bit squished as well. So it's showing me the two surfaces of the box. And I'll show you this on SolidWorks now. So here's our box drawn in SolidWorks. We've got the front, we've got the side, and we've got the top. My plan, I came along and looked down at the top of it. So when I came down and took it, we looked down here at the plan view. So here was my plan view. From the plan, I drew my elevation. So I came up and drew my elevation. The elevation just showed us the front of the object. So that was my elevation. If I get the box and turn it completely sideways, I get my end view. But you'll notice in between the elevation and the end view, if I come back along, here is the view we seen in our auxiliary elevation. We can see the front and we can see the side all at once. And so you can see when we go from the very, very front, as soon as I move it, I start seeing an auxiliary elevation. There, I now see an auxiliary elevation because I can see the front and the side. And the more I turn it, the more of the side I can see until I see nothing but the side. So that's my end view. So an elevation is between the end view and the elevation. If I go back then to my drawing, again you can see it, and even though it's turned a little bit sideways on the page, that doesn't really matter. We'll fix that in a minute. I've got the side and the front. And I can put multiple views on the one drawing. So instead now of having just my elevation, my auxiliary elevation at the side, I can draw a normal elevation. So I can come up here. I'll have to come up a little bit higher than the usual 20 millimeters, but that doesn't actually matter. I'll take my heights up from plan, draw an XY line, as we always do, XY line. And again, the height of the box was 30. Here is my box. So now what I've got is an elevation, plan, and an auxiliary elevation. So the three views all together. I'll cut the two of these apart and you'll see the similarities between the two. Just to finish off then, so as I said, our original plan, we drew our elevation, and you can see that the three elevations I've put up, so I've cut the elevations out of the other two questions, and you can see that, well, the two elevations here are identical. My auxiliary elevation, the important thing to see is that the heights are the same. So when I look at my elevations there, the height of this auxiliary elevation is 30, the height of the original elevation was 30. So what that means is that you can copy heights between any elevation. If you've got a normal elevation, or you've got an end view, you can copy the heights, or if you've got an auxiliary elevation, you can copy the heights. So I can take the heights from this elevation, bring it over to this elevation, or I could take the height from this elevation and copy it into an end elevation, and that's what these are used for copying heights. Give the drawing a go, see how you get on with it.